വീട്ടിലേക്ക് മടങ്ങി വന്നിട്ട് അമ്മ പാചകം ചെയ്യുന്നു, വീട് വൃത്തിയാക്കുന്നു, മറ്റു വീട്ടുജോലികളും ചെയ്യുന്നുണ്ടല്ലോ.
സമ, നിന്നോട് ഇതെല്ലാം പറഞ്ഞതാരാണ്? എല്ലാ വീട്ടിലും അമ്മ വീട്ടുജോലികൾ ചെയ്യുകയും പാചകം ചെയ്യുകയും ചെയ്യുന്നു. നമ്മുടെ സമൂഹത്തിൽ ഇത് സാധാരണമാണ്, അതിൽ തെറ്റൊന്നുമില്ല.
ഇല്ല അച്ഛാ, ഇത് തെറ്റാണ്. ചില സാഹചര്യങ്ങളിൽ ഒരു ലിംഗഭേദം മറ്റൊന്നിനേക്കാൾ ശക്തമാക്കുന്ന അത്തരം വിശ്വാസങ്ങളെ കുറിച്ചും എന്റെ അധ്യാപകൻ പറഞ്ഞു. നമുക്ക് എല്ലാവർക്കും പാചകം ചെയ്യേണ്ടത് അമ്മയുടെ കടമയല്ല. പിന്നെ നാം എല്ലാവരും ഒരുമിച്ച് പ്രവർത്തിക്കുകയും പരസ്പരം സഹായിക്കുകയും ചെയ്യണമെന്ന് മാഡം പറഞ്ഞു.
അതെ സമ, നിങ്ങളുടെ ടീച്ചർ പറഞ്ഞത് ശരിയാണെന്ന് ഞാൻ മനസ്സിലാക്കുന്നു. എന്റെ തെറ്റ് ഞാൻ മനസ്സിലാക്കി. നാളത്തെ നമ്മുടെ ഷിംല യാത്രയിൽ ഞാൻ നിങ്ങളുടെ അമ്മയെ പാചകം ചെയ്യാനും ബാഗ് പാക്ക് ചെയ്യാനും സഹായിക്കും. നന്ദിയുണ്ട് മോളെ, എന്റെ തെറ്റ് നീ എനിക്ക് മനസ്സിലാക്കി തന്നതിന്.
എന്റെ വീട് ഒരു ഉദാഹരണം മാത്രമാണ്. അവിടെ എല്ലാ ലിംഗഭേദങ്ങളും തുല്യമായി പരിഗണിക്കപ്പെടുന്നില്ല. അതിനാൽ ഇത്തരം സ്റ്റീരിയോ ടൈപ്പുകളെ അഭിസംബോധന ചെയ്യുകയും അവയെക്കുറിച്ച് സംസാരിക്കുകയും ചെയ്യേണ്ടത് ആവശ്യമാണ്. എന്റെ വീട്ടിലെ ഈ പ്രശ്നത്തെക്കുറിച്ച് ഞാൻ ചർച്ച ചെയ്തതുപോലെ എല്ലാവരും അത് ചെയ്യണം. വേദ്, നിനക്ക് എന്ത് സംഭവിച്ചു? നീ എന്തിനാ ഇത്ര ഭയപ്പെടുന്നത്?
ദീദി, ഞാൻ ഇവരെ വല്ലാതെ ഭയപ്പെടുന്നു. ആരാണ് ഈ ആളുകള്?
വേദ്, ഇതിൽ ഭയപ്പെടേണ്ടതില്ല. ട്രാൻസ്ജെൻഡറുകൾ നമ്മെ പോലെയുള്ള മനുഷ്യരാണ്. അവരുടെ ജൈവിക ലിംഗത്തിന്റെ അടിസ്ഥാനത്തിൽ നിയുക്തമാക്കിയ ലിംഗത്തിന്റെ പങ്ക് തിരിച്ചറിയാത്തവർ. എന്റെ ക്ലാസ് ടീച്ചർ മാം പറഞ്ഞു, ഓരോ വ്യക്തിയുമാണ് അവരുടെ ലിംഗഭേദം തിരഞ്ഞെടുക്കേണ്ടതെന്ന്. അവരുടെ ലിംഗഭേദം നമ്മൾ നിരീക്ഷിക്കരുത്. അതിനാൽ ഭയപ്പെടേണ്ട ആവശ്യമേ ഇല്ല.
പക്ഷെ ചേച്ചി, അവരെന്തിനാ എല്ലാവരുടെ അടുത്തേക്ക് പോകുന്നത്?
ട്രാൻസ്ജെൻഡർമാർക്ക് സമൂഹം തുല്യ അവസരങ്ങൾ നൽകുന്നില്ല. അതിനാൽ അവരുടെ ദൈനംദിന ആവശ്യങ്ങൾ നിറവേറ്റുന്നതിൽ വെല്ലുവിളികൾ നേരിടുന്നു. അതിനാൽ അവർ ആളുകളോട് പണം ചോദിക്കുന്നു. മാ, പാപ്പ, നമുക്കവരെ സഹായിക്കാമോ?
ഇതെല്ലാം ഉടനടി നിർത്തണം. ഓരോരുത്തർക്കും അവരാഗ്രഹിക്കുന്നത് പോലെ ജീവിതം നയിക്കാൻ സ്വാതന്ത്ര്യമുണ്ട്. നിങ്ങൾ എല്ലാവരും അവരോട് ക്ഷമ ചോദിക്കണം. അത് വീണ്ടും ചെയ്യരുത്.
ഞങ്ങൾ ഞങ്ങളുടെ തെറ്റ് തിരിച്ചറിയുന്നു. ഞങ്ങൾക്ക് ലജ്ജ തോന്നുന്നു.
നന്ദി സാർ. ലിംഗഭേദം അല്ലെങ്കിൽ ജീവിതം തിരഞ്ഞെടുക്കുന്നത് നമ്മെ ദുർബലരാക്കുന്നില്ലെന്നും ഈ അടിസ്ഥാനത്തിൽ നാം വിവേചനം കാണിക്കരുതെന്നും ആളുകൾ മനസ്സിലാക്കേണ്ട സമയമാണിത്.
അവർ പറഞ്ഞത് ശരിയാണ്. നമ്മൾ എല്ലാ മനുഷ്യരെയും ബഹുമാനിക്കാൻ പഠിക്കണം. അവരെങ്ങനെയായിരുന്നാലും അതേപടി അംഗീകരിക്കാനും നാം പഠിക്കണം.
ഓരോ കുടുംബത്തിലും സമൂഹത്തിലും ലിംഗസമത്വം വളരെ പ്രധാനമാണ്. കുട്ടിയുടെ മാതാപിതാക്കൾ അവരുടെ ആദ്യത്തെ റോൾ മോഡലുകളാണ്. മാതാപിതാക്കൾ ഒരുമിച്ച് വീട്ടുജോലികൾ ചെയ്യേണ്ടതും അവരുടെ പ്രായവുമായി ബന്ധപ്പെട്ട ലിംഗവുമായി ബന്ധപ്പെട്ട പ്രശ്നങ്ങളെക്കുറിച്ച് കുട്ടികളോട് സംസാരിക്കുന്നതും പ്രധാനമാണ്. അതിലൂടെ അവർ കൂടുതൽ അറിവുള്ളവരും ലിംഗപ്രതികരണ ശേഷിയുള്ളവരും ആദരവുള്ളവരുമായി തീരുന്നു. ലിംഗഭേദം, ജാതി, മതം, സാമൂഹിക, സാമ്പത്തിക അല്ലെങ്കിൽ വിദ്യാഭ്യാസ തലങ്ങൾ എന്നിവയ്ക്കും അപ്പുറത്ത് എല്ലാവരും പരസ്പരം ബഹുമാനിക്കണം. ഈ സുപ്രധാന മൂല്യങ്ങൾ ലിംഗസമത്വ പ്രതിഷ്ഠിത സമൂഹം കെട്ടിപ്പടുക്കുന്നതിനുള്ള ശക്തമായ അടിത്തറ ഉണ്ടാക്കുന്നു.
Swayam Prabha, Digital India, Educated India.
Welcome to this lecture. Over the last couple of lectures, we have been looking at the software quality management issues, and if you remember, we had said that for effective quality management, an organization must have a quality system, and there are several quality standards, quality system standards that are available, used throughout the world. We had discussed about ISO 9001, and then we had been looking at the Software Engineering Institute capability maturity model. We had looked at the 5 models and what are the quality system that is required at the different levels, the 5 levels of SEI CMM and the quality system requirements at each of the level. And also we had said that the CMM gives a stepwise approach to improve the quality at an organization, and this is known as the KPAs or the key process areas. An organization at a certain level that wants to improve its quality standard to the next level will have to incorporate certain key process areas. It has to focus on improving some key process areas that is clearly defined by SCI CMM. In the last lecture, we just started looking at the key process areas. Now, let us continue from there. We will first look at the key process areas, and then we will compare the CMM with ISO 9001, and after that we will look at the personal software process. The key process areas are defined for every maturity level of the SCI CMM. The KPA identifies the process areas that an organization at a lower level must focus to reach this level. That is, suppose an organization is assessed at level 2 and it needs to improve its process, its quality system to level 3, then it must look at the KPAs identified for level 3 and focus on those. In that sense, the KPI is a very important concept here in the CMM, and it gives a step by step approach to improve the quality at an organization. For the level 1, there are no KPIs, because every organization by default is at level 1, it does not need even a process. So, there is no process areas, key process areas identified for level 1. Now, let us look at the level 2 KPIs, that is, if an organization is assessed at level 1, what are the process areas it must focus to improve its quality system to level 2. The first thing identified in the KPIs is requirements management. That is, the organization must have proper requirement specification, and also how does it manage the requirements, that is, the changes in the requirements, how are these controlled. This is important because requirements is the basis for planning and managing a software project that is identified by the CMM. Requirements is a fundamental document, is a basic document which is required for many purposes, including planning and managing a software project. Another aspect, process area, which is highlighted is the project planning and monitoring. So, this is basically the software project management. Unless a organization has a project manager who estimates the size, cost, makes plans according to the size, cost, develops a schedule and then monitors the progress, the organization cannot be assessed at level 2. One of the emphases of the level 2 process is the project management. It is identified that project management is one of the basic aspects of a project, without which the project is hard to become success. Another issue that is process area that is identified is configuration management. A configuration management tool must be used so that various documents can be put under configuration control. The requirements document, the design document and so on, so that the changes to this can be authorized, that is who changes. It is not that anybody can change, an authorized person can change the document, and also it should be possible to identify the latest configuration or the latest version of the document, and also it would be possible to find out what changes have occurred so far and so on. The ones that are the process areas that are identified for level 2 are some of the basic aspects of a software project, without which it is very difficult to go to the higher levels. Going to level 3, level 4 etc., without incorporating these basic process areas would be counterproductive. The other process area is subcontract management. Every project at some point or other needs to give out work, well defined pieces of work to other vendors. And how are these specified? Is the contract clearly specified? What is the work to be done? And when getting the delivery, is it checked against those specifications? So, those are subcontract management. So, the level 2 KPIs are 4 important KPIs. There are other KPIs, but we have just highlighted here the most important ones: requirements management, software project planning, configuration management and subcontract management. Just represented this in a diagrammatic form here. The level 2 KPIs are 4 process areas: requirements management, software project management, that is software project planning, monitoring and so on, software configuration management and software subcontract management. The level 3 KPIs are the ones, are the process areas which a level 2 organization must focus and incorporate in order to improve its process to level 3. The level 3 KPIs are process definition and documentation. In level 2, different developers might be using their own process, but there is no standard understanding of which process is being followed. There is no documented process available in the organization, whereas in a level 3 organization, the process that will be used by all developers is clearly defined and it is documented in the form of a process handbook. Reviews are carried out at various stages. The requirements are reviewed, design is reviewed, code is reviewed and so on. And the third process area is training program. It is identified that the skills for software development is continually changing, and unless the developers keep up with the latest developments, it would be hard for a project to succeed. And therefore, periodic training program is another issue which is highlighted by the level 3. Represented this in the form of a diagram, 3 important level 3 KPS training program, peer reviews of various documents and process definition and documentation. The level 4 requires measurements of the process performance. Both the process and product metrics are obtained, and there is a quantitative process management, that is based on the measurements on the process and the product. If there is a deficiency somewhere, then it is identified why this is occurring. Maybe the development team is not strictly practicing some process, and therefore it focuses on identifying and correcting the causes of variation. If the defect rate that is identified after testing is high, then possibly the testing was not proper. Maybe the testing was not done rigorously, and therefore the project manager identifies that what caused the metrics to miss the specified values, and then it takes countermeasures so that the process variation is reduced. In summary, here for level 4 KPS, process and product measurements, and using these measurements, quantitative process management is practiced. Here, if there is a deficiency in any of the measured attributes, it is identified and corrective action is taken. But one thing I must point out, that the corrective action here does not really imply changing the process. For example, the testing is not effective because certain types of tests were not documented in the process document. That is not identified actually at level 4. The level 4 only tries to find out why there is a variation in the process, that is sometimes there are more defects, for example, and then identifies what action needs to be taken by the project manager to correct that deficiency. The level 5 KPA, on the other hand, it one of the focus is defect prevention, that is identifies what is causing the defect, and then if necessary change the process. The level 4 assumes that the process is all right, no changes required, only the way it is enforced or practiced is causing the process variation, which is causing the defects. Whereas in the level 5, the defects are analyzed, their causes, and if necessary the process would be changed. The other process area that is identified as the level 5 KPA is technology change management. In the area of software development, the technology changes rapidly, and therefore there must be a group in the organization whose sole work is to identify latest and beneficial new technologies and transfer these into the process and organization wide. The different tools that are become available, new methods, new processes, these are all identified and incorporated into the process. The other process area that is identified is process change management. The process continually changes in a level 5 organization, and therefore, the process itself must be put under configuration management, so that the latest process can be identified. There can be different versions of the process which are applicable to different teams, and therefore, the process changes need to be managed. Otherwise, what is the latest process, latest state of the process would be difficult. The process itself is put under configuration control. In the level 4 KPA, we had identified quantitative measurement on the process and product, and based on this, the project manager identifies deficiencies and determines what is causing the variation and takes corrective action. Some of the metrics that are deployed, here there are few examples: the estimated source lines of code and the actual lines of code. The estimated source lines of code and the actual source lines of code. Across project, the estimated lines of code and the actual lines of code, the variation must be bounded. If for some project the estimated source lines of code is very different from the actual source lines of code, then the project manager needs to introspect and identify what causes the variability, what aspects were not considered, what went wrong, and so on. The number of issues raised during code inspection, the number of defects detected during unit testing, the number of defects detected during system testing, these are also important metrics. The number of issues raised during code inspection, if these are much smaller compared to the defects detected during unit and system testing, that means the code inspection is not working properly. And similarly, if the number of defects detected during system testing is too many, then possibly the unit testing and code inspection did not work properly. So far, we have looked at two quality standards, the ISO 9001 and ACI CMM. Let us quickly compare these two standards. The first thing to note is that ISO 9001 is awarded by an international standards body, but Software Engineering Institute is not a standards body. It has just made some recommendations to the Department of Defense, and which we are using, and therefore, the ISO 9001 can be quoted in official documents and communications, and these can be accepted where these are given. On the other hand, the ACI CMM assessment is purely for internal use, that is, an organization wanting to improve its process uses the ACI CMM assessment, or an organization trying to select a vendor uses its own CMM assessment on the organization. The second issue is that the ACI CMM is very focused on the software industry, whereas the ISO 9001 is used across various industries, and therefore, the ACI CMM addresses many issues which are specific to the software industry, which are not really taken care by the ISO 9001. And also the SEI CMM targets for total quality management. Unlike the ISO 9001, the original ISO 9001 document, which was proposed in 1987, it targets only quality assurance, that is the level 3 of SEI. So, roughly the ISO 9001 that was brought out in 1987 corresponds to the level 3 of the SEI CMM, but of course, the ISO 9001, the 2000 version, the one that came out in 2000 version and later, they also target for TQM. Another major difference is that the ISO 9001 provides a go no go solution, that is, an organization either qualifies for ISO 9001 or does not. Whereas the SEI CMM, it provides a step by step approach by which an organization can improve its quality, that is starting at level 1 or very poor quality system, it can reach level 5 through a step by step approach. It provides a way for gradual quality improvement over 5 stages, and also it clearly identifies at each level what is the most pertinent or important process area that it needs to focus. That is, if a level 2 organization, without really focusing on level 3 KPAs, it tries to focus on level 4 KPA, then it will be counterproductive. Let us say a level 1 organization, without really practicing the project management, configuration management, requirements management, etc., it tries to have a defined and documented process. It won't be counterproductive. It would be counterproductive, because the managers would be overwhelmed by schedule and budget pressure, because the basic project management aspects are not there, the configuration management is not there, then having a process and using it will not benefit much. So, this is a tabular comparison. ISO is a certification, whereas CMM is just an assessment. ISO is generic, used across all industries. CMM is used for software. ISO requires yearly recertification, whereas in CMM it is not necessary that it has to be reassessed. ISO either pass or fail, whereas CMM are 5 levels through which an organization can improve its quality system. ISO is actually a third party certification. ISO does not give the certification, as you had said. It is only the accreditation agencies for specific country, they provide the certification, whereas CMM there is no certification actually. But then over the years, lot of CMMs came into place. CMM for software development, CMM for systems engineering, that is both hardware and software combined development, CMM for software acquisition, people CMM or the CMM for people management, security engineering CMM, etc. These are all pertinent, these are all relevant to an organization, but then each had its different structure, different terms were used, the different ways of measuring the maturity, which caused confusion. And when an organization tries to use CMM as a whole for all its activities, including acquisition and so on, It was very hard because these had different terminologies and different ways of measuring the maturity. And also, if multiple areas an organization had to select supplier, it was very difficult. And with this, the CMMI was proposed in 2002, and later it has been revised several times. The main idea here is integrating a large number of CMMs that an organization would have to deal with into a single one. But then there are three flavors of CMMI. One is for development, where there is which is applicable for software engineering, system engineering, collaborative teams, and acquisition of suppliers, acquisition from suppliers. There is CMMI for service industries. These are used across different industries, from taxi aggregators to call centers. They use CMMI for service, and then CMMI for acquisition, which is used for acquiring products and services. We are already at the end of the lecture time. We will just stop here, and in the next lecture we will discuss about the personal software process, or PSP. Thank you.
അമ്മേ നോക്കൂ, എപ്പോഴും അമ്മ പാടും. ഞാൻ അമ്മയെ വളരെയധികം സ്നേഹിക്കുന്നു.
അന്തര, നീ 2 തരം റിബണുകളാണല്ലോ കെട്ടിയിരിക്കുന്നത്.
അതെ അമ്മേ, എനിക്ക് 2 നിറങ്ങളും ഇഷ്ടമാണ്. അതുകൊണ്ടാ 2 ഞാൻ ഒരുമിച്ച് കെട്ടിയിരിക്കുന്നത്.
ശരി, നീ സന്തോഷമായിട്ടിരിക്കെ. നിന്റെ ലഞ്ച് ബോക്സ് എടുക്കണേ.
ആരും എന്നോട് സംസാരിക്കുന്നില്ല. ഒരുപക്ഷെ അവരുടെ ഗ്രൂപ്പിന്റെ ഭാഗമാകാൻ എനിക്ക് യോഗ്യതയില്ലായിരിക്കും. എല്ലാവർക്കും മനോഹരമായ ടിഫിൻ ബോക്സ് ഉണ്ട്. എല്ലാവരും ഒരുമിച്ച് ഭക്ഷണം കഴിക്കുന്നു. ആരും എന്നോടൊപ്പം ഭക്ഷണം പങ്കിടുന്നില്ല. ഞാൻ എപ്പോഴും ഒറ്റയ്ക്കാണ്.
ഹലോ അന്തര, നീ എന്നോടൊപ്പം നടക്കാൻ വരുന്നുണ്ടോ? നിനക്ക് സുഖമാണോ മോളെ? നീ അല്പം അസ്വസ്ഥയാണെന്ന് തോന്നുന്നല്ലോ. കുഴപ്പമൊന്നുമില്ലല്ലോ?
എനിക്ക് ആരും ചങ്ങാതിമാരില്ല. എല്ലാവരും സംസാരിക്കുന്നതും കളിക്കുന്നതും പാടുന്നതും കേൾക്കുമ്പോൾ ഞാൻ ഒറ്റയ്ക്കാണെന്ന് എനിക്ക് തോന്നുന്നു. ഞാൻ ഗ്രൂപ്പിന്റെ ഭാഗമാകില്ലെന്ന് ഞാൻ കരുതുന്നു. എന്നെ ആരും കാണാൻ ആഗ്രഹിക്കുന്നില്ല. ആരും എന്നോട് സംസാരിക്കുന്നില്ല. ഞാൻ എപ്പോഴും ഒറ്റയ്ക്കാണ് ഭക്ഷണം കഴിക്കുന്നത്.
അന്തര, നീ നിന്റെ വികാരങ്ങൾ പ്രകടിപ്പിച്ചതിൽ ഞാൻ അഭിമാനിക്കുന്നു. നിന്റെ അമ്മ നൽകിയ പോഷകസമൃദ്ധമായ ഭക്ഷണം മനോഹരമായ ടിഫിൻ ബോക്സിനേക്കാൾ മികച്ചതാണ്. ചിലപ്പോൾ ഇത് നിനക്ക് വളരെ വെല്ലുവിളിയായിരിക്കും. പക്ഷേ നിന്റെ ഉള്ളിൽ അത്തരം സാഹചര്യങ്ങളിൽ പോലും ക്രിയാത്മകമായി പ്രവർത്തിക്കുവാനും ചിന്തിക്കുവാനുമുള്ള കഴിവുണ്ട്. നീ ഒറ്റയ്ക്കല്ല. നീ തിരഞ്ഞെടുത്ത വഴികളിൽ അത്തരം വികാരങ്ങൾ കൈകാര്യം ചെയ്യാൻ നിനക്ക് കഴിയും.
എന്റെ വികാരങ്ങൾ നിയന്ത്രിക്കാൻ കഴിയാത്തപ്പോഴെല്ലാം ഞാൻ ഈ ഗാനം ആലപിക്കണമെന്നും അതെനിക്ക് സമാധാനം നൽകുമെന്നും എന്റെ അമ്മ പറയാറുണ്ട്.
ഓ, അതുകൊണ്ടാണ് നീ ഈ പാട്ടും പാടി മൂലയിലിരിക്കുന്നതല്ലേ? ഗുഡ് മോർണിംഗ് കുട്ടികളെ, ദയവായി ശ്രദ്ധിക്കൂ. ഗുഡ് മോർണിംഗ് കുട്ടികളെ, ദയവായി ശ്രദ്ധിക്കുക. നമ്മുടെ സ്കൂൾ ഒരു ഇന്റർ സ്കൂൾ ആലാപന മത്സരം സംഘടിപ്പിക്കുന്നുണ്ട്. നിങ്ങൾക്ക് അതിൽ പങ്കെടുക്കണമെങ്കിൽ ഇവിടെ വന്ന് ക്ലാസ്സിൽ കുറച്ച് വരികൾ പാടുക. ശരി, നമുക്ക് ആരംഭിക്കാം. നല്ല ശ്രമം കുട്ടികളെ. മറ്റാരെങ്കിലും? അന്തര, നിന്റെ കഴിവുകൾ ക്ലാസ്സിൽ കാണിക്കാൻ നീ ആഗ്രഹിക്കുന്നുണ്ടോ?
അവളുടെ മുടി ഒന്ന് നോക്കൂ.
അവള് 2 വ്യത്യസ്ത നിറങ്ങളുടെ റിബണാ കെട്ടിയിരിക്കുന്നത്. എന്തൊരു വണ്ടിയാണ്.
മാഡം വളരെ നല്ലവളും സഹായിയുമാണ്. അമ്മ എന്നെ പാടാൻ പ്രചോദിപ്പിക്കുന്നു. എനിക്ക് നന്നായി പാടാൻ കഴിയും. എനിക്ക് എന്റെ കഴിവ് കാണിക്കാൻ കഴിയും. One day I'll fly high beyond the dawn.
അന്തര തന്റെ വെല്ലുവിളി നിറഞ്ഞ വികാരങ്ങളെ നിയന്ത്രിച്ചു. ക്ലാസ്സിന് മുന്നിൽ നിന്ന അതേ ഊർജത്തോടെ ഇന്റർ സ്കൂൾ ആലാപന മത്സരത്തിൽ വീണ്ടും തിളങ്ങാൻ അവൾ തയ്യാറാണ്.
ആഹാ, ഈ പെൺകുട്ടിയുടെ ശബ്ദം എത്ര മനോഹരമാണ്. എനിക്ക് ഇവളുടെ പാട്ട് വളരെ ഇഷ്ടമായി.
ഇതാണ് നമ്മുടെ മകൾ.
ഇന്റർ വിദ്യാലയ ആലാപന മത്സരത്തിന്റെ 1ാം സമ്മാനം അന്തരയ്ക്ക്.
വികാരങ്ങൾ മനസ്സിലാക്കുകയും നിയന്ത്രിക്കുകയും ചെയ്യുന്നത് വളരെ പ്രധാനമാണ്. നമ്മുടെ കഴിവുകൾ കാണാനും കേൾക്കാനും അറിയാനും സ്പർശിക്കാനും അനുഭവിക്കാനുമുള്ള നമ്മുടെ കഴിവ് സ്വയം അവബോധത്തിന് ഒരുപോലെ പ്രധാനമാണ്. വികാരങ്ങൾ പ്രകടിപ്പിക്കാനുള്ള കഴിവ് കൗമാരത്തിൽ വളരെയധികം പ്രാധാന്യമർഹിക്കുന്നു. കൗമാരക്കാർ വൈകാരിക സമ്മർദ്ദം നേരിടുന്ന പ്രായം. എല്ലായ്പ്പോഴും ഓർക്കുക, നിങ്ങൾ ഒറ്റയ്ക്കല്ല. മറ്റുള്ളവരുമായി നിങ്ങളുടെ വികാരങ്ങൾ പങ്കിടണം. നിങ്ങൾക്ക് സ്നേഹവും സഹകരണവുമുണ്ട്. നിങ്ങളുടെ മാനസികാരോഗ്യവും വൈകാരിക ക്ഷേമവും വളരെ പ്രധാനമാണ്.
Swayam Prabha. Digital India. Educated India.
Welcome to this lecture. Over the last couple of lectures, we had discussed some basic concepts in software quality management, and we had looked at quality standards, the ISO 9001 and ACI CMM. We had also compared these two standards, which will give us an insight as to which one is more beneficial to use for a specific organization. In this lecture, we will look at the personal software process. The ISO 9001 and ACI CMM are applicable to organizations. These look at the process that is being followed at the organization, and then they make recommendations on the quality issues of this process. But the need for a personal software process was identified because every individual uses his own personal process. These are actually a scaled down version of the industrial software process and are used by individuals, unlike the ACI CMM and the ISO 9000, which are used across an organization, across all projects in an organization. Here it focuses on the individual's working style or the individual's process. ISO 9000 and CMM, they just make an assumption that individuals have effective personal practices. But then how do the individuals improve their personal practices? Starting with poor practices, how can they improve their practices over stages, and that is the focus of the personal software process, or PSP. As we know, a process is the set of steps that somebody uses for doing a job. For example, a developer is given the task of coding a module. How does he go about? Does he just understand the module requirement and then start coding? Does he look at the module, make an estimate of the code, the coding time, and then really keep the time and then check whether he is according to the plan that he has made? Does he have a coding process, how to code? So these are the ones that are targeted by the PSP. The quality and productivity of an engineer is largely determined by his process. The PSP framework, it helps a software engineer to measure and improve the way he works. The individuals, they have their different styles of working, and it provides a defined process for the individuals, and of course, the individuals can fine tune and continually improve their own process. It helps individuals to incorporate certain personal skills and methods. For example, they can do estimation and planning for their own work. The project manager does estimation and planning for the project, but what about the developers? Do they do any estimation of their own work that is assigned to them? Do they plan out how to go about doing that work? And do they really track the performance against the plan they made? One of the most basic issues that has been pointed out by the personal software process is the time management. Unless the time is measured, it becomes very difficult or very erroneous. If somebody tries to do a boring activity which he does not really enjoy, then it will appear to be much longer than it is. For example, somebody, let us say, does not like to design, he likes to code, and he is asked to design. Even if he spends just few hours, he may say that I have been doing the design activity for a long time, and therefore, the time needs to be measured. Similarly, interesting activities seem very short. Somebody who enjoys doing coding and he has coded for, let us say, 8 straight hours, and you ask him that how long did he code, he will say that no, I just spent very little time in coding, I just done it all without spending too much time. For this reason, it is necessary to record the time for designing, for writing code, for compiling and removing the syntax errors, and then testing and removing the bugs. Plans have to be made by the individual. If he is given a unit to code, he has to plan how is he going to do it, has to write down the plan. For the design, must record the time taken in the log, and the plan must be okay, that is compared later with the log. For the coding, how much time really it took, compilation to remove syntax errors, how much time does it took, test to remove the bugs, how much time does it took, and these are all compared with the initial plan made, and a project plan summary is developed, and then a post-mortem is used to identify what went right, what did not go okay, how it needs to be improved, and so on. So, that is the basic of the PSP. Other than the time management and keeping records or logs, the other aspect which is highlighted by the PSP is planning. Starting with the problem definition, need to estimate what is the size of the work, what is the maximum, minimum, and estimated lines of code, and from this must determine how much minutes it will take. If an individual knows his coding speed, that is how many minutes per lines of code, then he can determine the maximum, minimum, and total or the estimated development time. And these must be entered in a project plan summary form, and once starts working must record the actual time, the planned time and the actual time must be recorded. The design, the specific format in which the design to be done, the developer must have his own standard, which is of course final output must be compliant with the required standard of the team, but the way he goes about designing in the specific format, he must identify and then record the design time in the time recording log. For the coding, must implement the design and should have his own way to go about coding, his own process. Some developers, they first write the function prototypes and then identify the variables and define them and then write the code. Some other developers may feel comfortable in first writing a simple version of the function and slowly enhancing that, adding more and more variables, parameters, and so on. But finally, the way the text is laid out, that also must be standard, and the coding time must be recorded in a time recording log. The compile to remove all syntax errors. Each time the program needs to be compiled and the syntax errors identified must be fixed until the program compiles satisfactorily, and this time is recorded in a log. Then the testing, here all the bugs have to be identified and fixed, and the time is recorded in a log. And finally, the post-mortem, where the project summary data, that is the planned time and the estimated time, are analyzed, and then the observations are written down post-mortem. If we represent it schematically, in the PSP there are 4 levels: PSP 0, PSP 1, 2, and 3. At the 0 level, only the measurements are done, that is the personal measurement, that is how much time somebody takes for a line of code, it is time per lines of code. The basic size measures that is given a work, does he estimate that how much time will it take, how many lines of code, and so on. In the PSP 1 level, the basic planning is done, the personal planning, that how to go about doing the work, when to do which one, this is planned, and there is a schedule that by this time I must do this, and so on. In the level 2 of PSP, the personal quality management and the design and code reviews. The developer himself reviews his design and code and writes in the form of a log. And in the PSP 3, the personal process evolution, not only the personal process has been defined, but the opportunity to improve the process is identified, and the process is continually changed at the level 3. Now, let us look at very briefly at Six Sigma. The Six Sigma initiative is a quantitative approach to eliminate defects. Again, this is applicable to all types of industry, from manufacturing, product development, service. It is applicable to all industries, and it incorporates statistical representation of the defects, and based on that one can conclude that how a process is performing. A defect is defined in Six Sigma as anything that does not fall within customer's tolerance limit. If something is a defect, but the customer is okay with that, that is not really a defect. In the Six Sigma, it argues for continuous process improvement, so that the variability in the process, the upper and lower limits that are set, these fall within 6 standard deviations above and below mean. We will not go into the detailed mathematical computations, how to define the 6 standard deviations and so on, but we will just say that to achieve Six Sigma, a process must not produce more than 3.4 defects per million opportunity. If we look at definition of a 5 sigma or 4 sigma, you can see that the number of defects acceptable are much higher. A 6 sigma process must not produce 3.4 defects per million opportunities. Here the defects are represented using a Pareto chart, and the defects that occur with the greatest frequency or that incur the highest cost are identified to take corrective action. Several Six Sigma methodologies are defined, like define, measure, analyze, improve and control, DMA-IC, define, measure, analyze, design and verify, or DMA-DV, and these are implemented by green belt and black belt workers, supervised a master black belt worker. We will not go into the nitty-gritty of Six Sigma methodologies. We do not have that much time in this course. We just looked at a very overall idea of the Six Sigma. We will now start looking at the software reliability issues. Now, reliability is a very important issue in software. The customers, they look for highly reliable software, they will not buy software which is not reliable, and therefore, it becomes a very important issue with the project manager to understand the nitty-gritty of reliability, and ensure that the final developed software has high reliability. Reliable software is a concern for all users, especially if it is used for some industry application. It is very crucial, and also reliability is an important determinant of the quality of the software. A software having poor reliability cannot be said to be a quality software. The users not only want a highly reliable software, but they need a quantitative estimation to be given to them about the reliability before they can make any buying decision. But how do we define software reliability? Informally, we can say that the reliability is basically the trustworthiness of the software or the dependability of the software. Intuitive definitions: trustworthiness, dependability. But can we give a more formal definition of software reliability? IEEE document in 1991 defines reliability as the probability of software working correctly over a given period of time under specified operating conditions. So here it is defined in terms of the probability